Okay, folks, we're going to start with section 2.5 now. And on section 2.5, okay, so this is 2.5. This is going to be used, we're going to use the unit circle again to find exact trig values of our special functions, okay? Sine, cosine, tangent, so on. Now, we talked last time about the unit circle, and we said that with the unit circle there, we had a circle drawn on our graph like so, and we said the radius of what made this special is that the radius of the unit circle was 1. Okay, so excuse my poor drawing, but the radius of the circle is 1. What we learned. Okay, so in that it followed this equation where every point on there is the point AB. Every point on the circle is the point AB, and the radius is 1. Okay? And if we wanted to find out the radian measure of certain angles, like for instance, this is 0 degrees, 90 degrees, 180 degrees, 270 degrees. If we wanted to find the radian measures, we had to multiply by pi over 180, if you remember. And so that gave us pi over 2 for our radian measure. And we got pi for this one, 3 pi over 2 for this one, and 2 pi for this one. Now this is 0 or 360. Remember, because when we go all the way back around, 0 and 360 are in the same spot. So 360 and 2 pi are equal to one another. 0 is just 0. So don't, whether it's a radian or whether it's a degree, 0 is just 0. So these are some angles we know, and I told you there were going to be special angles that we had along the way that you would be able to know. We looked through a few of them last time, the pi over 3, pi over 6, and pi over 4. We'll get more into that today. But these angles that you see in front of you, the ones that are on the axis, that you definitely know what the point is. Notice, we definitely know all 4 of these points because it has a radius of 1. These are special angles. They're called quadrantal angles. Quadrantal angles. Okay? And with quadrantal angles, it's very easy for us to find the answer. So for instance, if I had the sine of 90 degrees, the sine of 90 degrees. Well, remember, what is sine? Sine of x equals b in the unit circle, because remember our radius is 1. So if you want to write it as b over 1, that's fine. So you're always keeping the form of putting the radius on the bottom, but b, we're just going to say b. Okay, so look at 90 degrees, or pi over 2, and what is our b value? Well, our b value is 1. So the sine of 90 degrees is 1. We can figure that out very easily using our unit circle. Same thing for, let's look at a radian measure. Let's look at the cosine of pi. Now the cosine, remember, is the a coordinate. So let's go over here to pi. The a coordinate in this place is -1. So the cosine of pi would be -1. Would be -1. Okay, so tangent. Well, let's look at tangent here. Let's look at the tangent of -2 pi very carefully. Now, negative 2 pi, think of where you are here, okay? We're going in the negative direction, so that means we're starting here on the x-axis, and 2 pi means we're going all the way around this circle back to here. So basically, we're exactly where we started. So the point we're going to use to make this call would be this one right here, 1, 0. Now remember what tangent is. Tangent would be b over a. So in this case, this is going to be 0 over 1, which is 0. So the tangent of negative 2 pi is 0. Now what would happen if we did the cotangent of negative 2 pi? Well, here's where you've got to be careful, because look, cotangent is the reciprocal of tangent, so 0 over 1, this one is going to be 1 over 0 then. And 1 over 0 is undefined. Okay? So keep that in mind. As you're searching for these quadrantal angles, remember quadrantal angles will always be on the axis. Alright, so we know the quadrantal angles and their 4 points. We're going to be adding points to this unit circle all throughout section 2.5 until you have it filled. And you're going to need to write these down because you're going to need to memorize these. I will give you all kinds of formulas. I mean, a couple of pages worth of formulas for your exams. But the one thing I will not give you, okay, is the unit circle. You're going to have to memorize that. I know the people in class that are not memorizing their unit circles, because once you get on the test, you're missing unit circle problems. So you want to get to a point to where you don't have to write all this out. It's almost memorized. Okay, it's almost memorized. So let's go down to the next slide. And so we found the quadrantals, but we can also calculate some other ones or figure out the exact values of some other trig functions without the use of a calculator as well. Okay, so for instance, the multiples of pi over 4. The multiples of pi over 4. Okay, so we have our unit circle here. Okay, and so it looks like this. Now, we know this is 0. Okay, pi over 4. Pi over 4 is the same thing as 45 degrees. If you were to change it back to degrees, it would be 45 degrees. Get used to both. I want you to know both terminologies, but pi over 4 is the same thing as 45 degrees. And you can use your conversion factor to change that if you need to. Alright, well, whereas 2 pi over 4, 2 pi over 4 is actually right here, because we already know what 2 pi over 4 is. It's pi over 2, or 90 degrees. Okay, well, this angle right here would be 3 pi over 4, or 3 pi over 4 is the same thing as 135 degrees. Okay, notice I'm just adding 45 each time. Our fourth one would be 4 pi over 4, or just pi. We learned that a moment ago. Okay, our next one would be 5 pi over 4. Okay, and again, this is a multiple of this would be 180 degrees here. So this is a multiple of 45, so this is just going to be 225 degrees. Then we have 6 pi over 4, which is the same thing as 3 pi over 2. So notice what this is doing. You've got your multiples of 45, but they include some of your quadrantal angles that we already know. And this is 270 degrees. This is some of these quadrantal angles that we learned just on the last slide. Then we have 7 pi over 4. Or add 45 more degrees, and that's going to be 315 degrees. And then lastly but not least, you have 8 pi over 4, which is the same thing as 2 pi, or as we learned earlier, 360 degrees. So these are the multiples of pi over 4. Now, it's going to be very easy for us to figure out what pi over 4 is. Okay, so to find the exact values of pi over 4, think about what we have here. Okay, let's just look for the meantime, for the purpose of teaching you this. Let's look just at the first quadrant. Okay, I want you to look just at the first quadrant at pi over 4, or 45 degrees. So, what does that tell me? That tells me that this angle right here is 45 degrees. That angle right there is 45 degrees. So, or pi over 4, however you want to look at it. Alright, so if we were to draw a right triangle all the way down to the x-axis here, this would be a 90-degree angle here. So that would make this angle right here 45 degrees as well. Now I'm going to ask you to recall something from geometry. Okay? The thing I'm going to ask you to recall from geometry is the 45, 45, 90 triangle rule. 45, 45, 90 triangle rule. Now, what's so special about that? Well, in a 45, 45, 90 triangle, we know for a fact that because those two bottom angles are the same, that both of these sides, that both of these sides right here, this one and this one, are exactly the same. Okay? They are exactly the same. So, we call this, you may have heard it called something else. This is also called an isosceles triangle. An isosceles triangle. Okay? Both sides are the same. So we can figure this out. Because watch, we know what this hypotenuse is. This hypotenuse is 1 because the radius of this circle everywhere to every line here is going to be 1. Right? That radius is 1. So we know that one side, and since the sides are the same, we know that we can write the Pythagorean, and this is a right triangle, so we can use the Pythagorean theorem to solve. Now, what Pythagorean theorem are we going to be using? Well, we have to use one that relates the points. So notice our points here are in A and B. So A squared plus B squared equals 1. 1 being our hypotenuse. But we just said that this side and this side are exactly the same. So that means really what I have here is A squared plus A squared, which is actually 2A squared, which equals 1. So A squared equals 1/2. And A then would equal 1 over the square root of 2 once you take the square root of both sides. Now, A is representative of what value? A and keep in mind, folks, we're in the first quadrant here. When you take that square root of both sides, right here, remember this gives you a plus or minus answer, but we're only going to use the positive here. Why? A represents the x value, right? A represents our x value in our point. We're only going to use the positive version because we're in the first quadrant. If we were in the second quadrant, we would use the negative value of A instead of the positive value when you take that square root, because in the second quadrant, our x values are negative. I hope that makes sense. So our A value here is 1 over the square root of 2. 1 over the square root of 2. Well, that's nice to know. And guess what? We know what B is as well. Because since these two sides right here are exactly the same, we know that this one is 1 over the square root of 2. So guess what? We know for a fact that this point is 1 over the square root of 2. And this point is 1 over the square root of 2. Now, why is that important to us? Well, these angles are all multiples of 35 degrees. Okay? These angles are all multiples of 45 degrees. So, what that means, we know you don't have to worry about the quadrantals. They're not going to change. This is still, positive 1, 0. This is still going to be 0, 1. This is going to be negative 1, 0. Excuse my writing, this pen's acting kind of weird today. And this point here is going to be 0, negative 1. Okay, those quadrantal angles are going to be the same. But these other multiples of 45 are all going to follow the same pattern right here. The only difference, okay, let me state this, the only difference is going to be whether it's positive or negative based on the quadrant it's in. So for instance, this one right here, this 135 degrees here, the x value is negative in quadrant 2. So this is going to be a negative 1 over the square root of 2. And this one here is, our y value though is positive. So this is going to be a 1 over the square root of 2. And if you want to rationalize these and write them as the square root of 2 over 2, that is fine. Your book writes it like this, so that's how I'm writing it. You may hear me say square root of 2 over 2 at some point, because that's how I learned it. My teachers made me rationalize it. I'm not going to make you, because your book does it this way. Okay, so keep that in mind. So what about down here? It's going to be the same at 225. It's going to be the same pattern. The only difference here, and you need to make this note on your notes, okay, because I'm not going to write it up here. The only difference is in quadrant 3, both the x-coordinate and the y-coordinate are negative. So this is going to be -1 over the square root of 2. I just decided to write it up here and this is going to be -1 over the square root of 2 because it's in the third quadrant. Okay? What about the fourth quadrant? Well, hopefully you've seen the pattern now, and you know in the fourth quadrant, x values are going to be positive, and the y value will be negative. So this, folks, this is going to be your multiples of 45. So what you need to do in your unit circle so far, you should have the quadrantal angles and their points. You should have the multiples of 45 and their points. What you're going to want to do is leave yourself plenty of space. You're going to want to draw this very big on a sheet of paper. So because we're going to add the multiples of pi over 6 to this, we're going to add the multiples of pi over 3 to this, okay? Excuse me. So we're going to add tons more to this, okay? So keep that in mind as we're progressing along. Now, this will be the end of this particular video. We'll stop with the 45, 45, 90 here. We'll stop with the pi over 4. On the next video, we will do pi over 6 and pi over 3.